So anyway, it's great to be back here in New York and able to see people in a face-to-face environment after a couple of years of online events. And we've put together, I think, an interesting and varied program today for the Media over IP Networking Pavilion. And I'm going to kick things off with a discussion and an overview presentation about the AEMS roadmap for media networking interoperability. I'm Terry Holton. I'm an AEMS board member and also chairman of the audio working group. And as far as an introduction to the pavilion here, AEMS has partnered with the AES to present this IP networking technology pavilion. And we've done this a couple times in the past. At previous shows, we focused primarily on audio networking. But this year, we've decided to expand the scope quite a bit, and we've got a wider range of topics all related to professional media over IP networking. And of course, it's a program that's open to visitors freely attending either the AES or the NAB shows. So a bit of background about AEMS and who we are. AEMS is a not-for-profit trade alliance, and it's open to everyone, and it's funded by its members working toward one common goal. And that goal is described in the AEMS mission, which is to foster the adoption of one set of common, ubiquitous, standards-based protocols for interoperability over IP in the media and entertainment industry and also the professional audio-video industries. A bit of background to AEMS. Actually, before the establishment of AEMS, there was an organization called the Media Networking Alliance, or the MNA, which was formed in 2014 with a mission to promote the adoption of what was then the newly ratified AES22 standard. The Alliance for IP Media Solutions, or AEMS, was established at the end of 2015 with a mandate to bring IP solutions to market to offer complete interoperability based on open standards, to integrate seamlessly into media workflow environments, and to foster industry innovation and efficiency. And the initial focus at that time was on the broadcast or media and entertainment industry. Following a couple years of close collaboration, the MNA was merged into AEMS at the end of 2017. We found we had many common objectives, and the merger allowed us to create a larger and stronger organization that could focus beyond the broadcast to also include pro audio and pro AV markets. And following the merger, AEMS reached a peak of 100 members, which included many of the leading companies manufacturing equipment and also a number of the major broadcast companies. Now here's a slide showing the current members of AEMS, and hopefully you'll recognize a lot of these company names. Some of these companies have been with AEMS from the very beginning. Some of them even go back to the beginning of the MNA. But others have joined more recently, and particularly in recent times, we're getting more companies joining from the pro AV industry. Now, a bit of background about why AEMS was established. At the time AEMS was established, there was a lot of uncertainty in the industry about networking. Several different vendors and groups of companies were working together to develop proprietary networking solutions for the broadcast industry, and this created an environment of uncertainty and risk, which threatened to become a significant obstacle to the adoption of IP media networking. Vendors had to consider, and broadcasters had to consider, could they possibly choose the wrong networking solution? That doesn't necessarily mean it's an inferior solution, but if it didn't become widely adopted in the industry, they might find after a few years they had to change to a different solution, which could be an expensive change to make. So AEMS was established, and AEMS brought together a wide range of vendors and end users with the goal of establishing one set of common standards-based protocols for interoperability. The initiative resulted in the publication of the AEMS roadmap. There's been several versions of the AEMS roadmap. I'm going to be focusing obviously on the current one today. And AEMS' role in this process has been to help identify the requirements and then to foster the adoption of the standards and specifications that appear in the roadmap. AEMS itself is not a standards body, but our members include many of the most active participants in those standards bodies, and that includes organizations like the AES, SMPTE, AMWA, VSF, and others also in the IT industry. And it's all based on open standards. The roadmap consists of a set of IP standards that have been developed using a collaborative, non-proprietary approach. And as a result, it has the support of more organizations than any other, and is particularly well suited to support the current and future needs of the industry. So here we have now the current AIMS roadmap as it exists today. And I'm just going to take a look at this, provide a bit of an overview, and then in some of the sessions we have later today and tomorrow, we'll be going into more depth on some of these topics. So if we start on the left side of the roadmap, we see SDI over IP. And this is related to the SMPTE ST 2022-6 standard, which is for transport of high bitrate media signals over IP networks, and this was published in 2012. So this defines a mechanism for encapsulating the data carried in SDI, so component video, uncompressed audio, and ancillary information like subtitles and timecode, and transports it reliably with low latency over a local IP network. Here's a simple diagram that shows how you have the different elements, the data, the audio, the video coming in, being packetized, sent over the network, and on the other end it's depacketized. So this allows the use of off-the-shelf IT networking hardware to deliver uncompressed video and audio over a network, and it doesn't require specialized components or devices. It's easy to maintain audio-video synchronization, but it's not so easy to process just one part of a stream, like the audio, for example. Then we come to the next stage of the roadmap, and this is all about audio, and this is audio over IP as defined by the AES22 standard. And this is an AES standard for audio applications of networks, high-performance streaming, audio over IP interoperability. And this standard was first published in 2013, and there have been revisions published in 2015 and 2018. And just to describe briefly the background to AES67 and what it sets out to achieve, the original goal was to provide a method to connect disparate audio over IP systems, of which there were several at that time in the industry, and to achieve workaround-free networked audio interoperability. And AES67 is defined as an interoperability standard for high-performance audio over IP networks. And very importantly, it's based on existing and trusted IT standards. So this ensures compatibility with existing network infrastructure, and it also allows coexistence with other IT data. At the time the AES67 standard was being created and defined, a problem statement was identified. So at that time, it could be seen that audio over IP or networked audio could provide better and simpler connections between audio equipment. But at the same time, coupled with those many advantages, there was one clear challenge that presented itself, and that was compatibility. So the different audio over IP solutions offered connectivity within their system, but there was no standard to provide intersystem connectivity. And we can see that through this sort of simple diagram here. If you had a network of Dante devices, they could exchange audio with one another with no problem, but if you want to then send that audio over to a Ravenna network prior to AES67, you had to use some sort of workaround approach. And the reason for that is we have some fundamental incompatibilities between these different audio over IP solutions. On the left side here, you have a description of the many elements that go to making up such a solution. You have things like synchronization and transport and connection management and so forth. And we can see that each of these developers chose, in some cases, the same way to do things, but in most cases, slightly different ways to achieve each of those objectives. And so here we can see some of the differences between the different solutions, and as a result, you don't have compatibility between these different solutions. And that's where AES67 comes into the picture. AES67 defines the standards and the specifications to meet those different requirements so that you then can have compatibility between the different audio networking solutions. A couple things to mention here. Up at the top you see control and monitoring, and that's considered to be outside the scope of AES67. And then you have discovery, and it was decided with discovery that trying to define just one mandatory way to do discovery might hold back adoption of the standard. So instead, the AES67 standard references a few different ways that discovery can be handled. But with this baseline of common protocols and standards, AES67 enables audio interoperability between products that are based on these different network networking technologies such as Dante, Ravenna, QLAN, Livewire, WheatNet, and some others. And those networked audio solutions I just mentioned are complete solutions, whereas AES67 was not intended to be a complete solution. It can become the basis for a complete solution, but it will require other things to be added to it to be a complete solution. AES67 is a mode of operation that allows audio interoperability between the existing complete solutions. And as such, AES67 was intended to complement each of those solutions, not to compete with it. So that then takes us to the next part of the roadmap, which is a very significant part of it, described as standardized transport of audio, video, and ancillary elements. And this, of course, is all defined in the SMPTE ST2110 standard. This is a standard for professional media over managed IP networks, and the first parts were published in late 2017. So ST2110 is a suite of standards, which is important to recognize. It's not just a single standard. And it specifies the carriage, the synchronization, and the description of separate elementary essence streams over IP for real-time production, playout, and other professional media applications. And all of these elements can be routed separately and then brought together again at the endpoint. With ST2110, each component flow, audio, video, metadata, is synchronized to each other while remaining independent streams. Each media type is a separate packet stream, and it's easy to process individual components. Now, as I said, it's a suite of standards, and these are the 6 parts of the standard that are in the current AIMS roadmap, and I'm just going to provide a brief introduction to each of these parts. First, we have 2110-10, which is about system timing and definitions. And this defines such things as transport layer protocols, datagram size limits, the requirements for session description protocol, or SDP, and also clocks and their timing relationships. And some key parts of the 2110-10 include RTP for real-time transport protocol. This is based on RFC 3550 from the IETF. And this provides end-to-end network transport functions suitable for applications transmitting real-time data such as audio and video over multicast or unicast network services. And we have SDP, Session Description Protocol. This is based on RFC 4566 from the IETF. And SDP describes multimedia sessions for the purposes of session announcement, session invitation, and other forms of multimedia session initiation. And then we also have, very importantly, PTP, or Precision Time Protocol. And this part is based on an IEEE standard, 1588. And this is a method for distributing precise GPS-referenced time over an IP network. It's a proven technology used in multiple industries, which is very valuable, and it's used for synchronization and alignment of media signals. AES67 and ST2110 both make use of PTP. Moving to the next part of the suite of standards, we have ST2110-20, which handles the uncompressed video part of the solution. And this specifies the requirements and the payload format for the transport of uncompressed active video using an RTP format based on RFC 4175. The uncompressed video images are transported, just like SDI, but only the data that make up the active portion of each video frame is transported. So only the image samples or pixels that comprise the actual pictures that will be delivered to viewers are transported. And that method can significantly reduce the amount of data required to represent each frame of video. Moving to the next part of the suite of standards, we have ST2110-21, and this is about traffic shaping and delivery timing for video. So this specifies the timing model for senders and receivers of video RTP streams. And it defines 3 classes of devices based on their transmission timing behavior. So we have narrow linear, we have narrow, and we have wide. And the choice of those different classes will impact buffer requirements of network switches and receiver devices, and also, of course, sender-receiver compatibility. So just to briefly discuss those 3 different classes, NL, or narrow linear senders, they transmit their data at a very constant bit rate. Whereas narrow, but not necessarily linear senders, they may temporarily suspend transmission during the vertical blanking intervals. And then we have wide senders, and these are intended to support software implementations of ST2110. And these adhere to less rigorous transmission timing requirements. So Type W receivers can receive from any of these different types of senders, and this allows for the burstiness of data that you will often get with a software-based implementation. But of course, to do that, you need larger data buffers. And here's a diagram that shows these different classes of timing, delivery timing for video. You have at the top the narrow linear, where you have very steady packets being delivered with very little bit rate variation. Under narrow, where you've got the vertical blanking interval, you can have occasional gaps in the transmission of the packets. And then down at the bottom, you have the wide senders, where you're typically, based on a software implementation, you can find that there's quite a bit of variation in the timing and transmission of the data, including some gaps and including some burstiness. Next, we move to ST2110-30, the uncompressed PCM audio part of the solution. This specifies the payload format for linear PCM audio only. And very importantly, it's based on AES22. So at the time ST2110 was being developed, AES22 had already been available for a few years, and it was becoming widely adopted. It was proving that it was working well in the industry. So rather than define something completely new, SMPTE made the wise choice to base the audio portion of 2110 on AES22. But they did define some constraints, and so you can consider 2110-30 to be a constrained subset of AES22. And the reason for that was to achieve better interoperability by having a tighter operating point definition. And what you can see in this diagram is, if you look at the light blue sort of sphere, that represents all of the aspects of AES22. At the center, in more of a purple color, those are the mandatory parts of AES22. And what we have with 2110-30 in its primary operating point, the vast majority of it does overlap with the AES22 mandatory requirements, but a bit of it extends out into some of the optional areas of AES22. So the primary operating point defines 1 millisecond packet times, 2 and 8 channels per stream, a common PTP operating point, and an RTP offset of 0. And that was unique to 2110-30. That wasn't part of the mandatory requirements of AES22. So initially that maybe caused a little bit of concern that there could be some compatibility issues. But what we found more recently is that more and more developers of AES22 devices are now also using an RTP offset of 0, so there's much more seamless compatibility between AES22 and ST2110 devices. And then 2110-30 goes a bit further than that and defines a couple other levels, B and C, and these operating levels support a shorter packet time of 125 microseconds, which is ideal for low latency live production. That's part of the overall requirements of AES22, but it does go outside the mandatory part of AES22 requirements. And with level B, you can support up to 8 channels per stream, and level C gives you up to 64 channels per stream. So there's a little bit to consider. For the most part, AES22 and ST2110 are very compatible, and there's much in common between the two. But there are a few constraints that may need to be considered. So AIMS produced a white paper a few years ago, which explains this in a bit of detail. If you're interested in that, it can be downloaded from the AIMS website, or we have a few copies of it at the back of the room here if you'd like to pick it up here. Now, moving to the next part of the suite of standards, we have the other part relating to audio, which is ST2110-31, and this is for handling of transparent AES3 audio transport. So this was published in 2018, and it specifies the real-time RTP transport of AES3 audio signals over IP networks referenced to a network clock. And it can transport any format which can be encapsulated in AES3. So this could be L24 PCM with AES3 subframe metadata like channel status bits, or it could be non-PCM audio and data formats such as Dolby E. So with that added to the suite of standards now, ST2110 can handle all forms of audio as standardized by AES67 and AES3. And then the last part of the suite of standards is relating to ancillary data. This is 2110-40. And this specifies the method of transporting ancillary data via RTP. And it maps the ancillary data packets into RTP packets that are transported via UDP-IP. And this includes such things as timecode, closed captions, and subtitles. And it enables those packets to be moved synchronously with the associated video and audio essence streams. So that covers the 6 elements of 2110 that are currently in the AIMS roadmap, but there are further ST2110 developments ongoing. For example, one of the most recent parts of the standard to be ratified is ST2110-22, and this defines constant bitrate compressed video transport. This is not yet included in the AIMS roadmap, but could be in the future. And there are other parts of 2110 that are under development and could be published in the future, and AIMS will continually assess those and consider updating the roadmap when appropriate. And this brings us then to the final section of the current roadmap on the right side here, described as system environment and device behaviors. And this is covered by a document from the JTNM called TR1001-1. Now, if anybody doesn't know what the JTNM is, it's the Joint Task Force on Network Media, and it's a group of companies led by AMWA, SMPTE, VSF, and the EBU. And their mission is to help drive development of a packet-based network infrastructure for the professional media industry. And the TR1001-1 was developed through learning from the experiences of the first ST2110 broadcast installations. And looking at what was required beyond just the ST2110 suite of standards, this document was developed to address the challenges those early adopters faced. And the goal of the document is to enable the creation of network environments where an end user can take delivery of new equipment, connect it to their network, and configure it for use with a minimum amount of human interaction. That's the goal. It enables simplified network configuration, registration, and connection management for SMPTE ST2110 media nodes, and it also includes some previously published specifications from AMWA that were already in the AIMS roadmap, and these are the NMOS ISO4 specification that defines how devices are discovered and registered in the network, and also ISO5, which specifies the connection management. But TR1001-1 goes beyond this and describes a range of other environment behaviors that address how devices work together within the context of a network system. And importantly, it utilizes a number of IT industry technologies. And I think we've seen, looking throughout these standards, wherever possible, existing IT standards are being used. And there's no reason to necessarily reinvent those elements specifically for IP media networking. And related to all this is a useful document from the EBU called the Technology Pyramid. And I think we can see that a lot has been accomplished in the last few years on this subject, but there's still more work to be done. And the EBU Technology Pyramid project set out to identify the gaps in the technologies and also the availability of standards-based solutions. And they have created a pyramid that provides a visual representation of how the technology has developed and what areas still require further progress. So this is the current technology pyramid. There's quite a bit on this, so I don't have time to go into this in detail in this session, but just to explain that we have different elements in this pyramid, building up from the bottom where you have security. It moves up through configuration and monitoring, operational control, time and sync, and at the top we have media transport. And under each of those categories you can see the relevant standards and specifications that address those requirements. And I think the kind of the important thing, or the visual thing about this pyramid, is you can see color coding that tells you where we're at with regard to meeting those requirements. So at the top, under media transport, it's color-coded green, which means the the technologies and the available products and solutions in the market are widely available. If we move down to the next area of time and sync, it's mostly green, mostly widely available, but some yellow, which means partially available. And as we go further down the pyramid, we also introduce some red coding, which means at this time still rarely available. So obviously if you looked at the previous version of this pyramid, you'd see a lot more red and less green, and it's moving in the right direction toward more green parts of the pyramid. And we hope to continue in that direction, of course. And in order to monitor how this is progressing, a very important activity from the JTNM is what they call tested events. And these events bring together many companies, many of the leading manufacturers of networking equipment in the broadcast industry, pro audio, pro AV industries. And they spend a full week doing some extensive testing and to be able to evaluate how well products are actually meeting the standards that are published. And it then offers a more documented insight into how equipment is aligning with the ST2110 standard, and it also includes testing of the JTNM TR1001 and the AMWA NMOS specifications. It's important to mention this program is not a certification program, but it could be seen as representing a snapshot in time of how different vendors' equipment is conforming to the key parts of the standards and specifications. And these tests have been going on for several years, and through the different test reports each year, we can see the progress that is being made. More and more devices are more properly meeting the requirements of the standards. The latest event took place just a couple months ago in Germany, and a report from that event will be made a little bit later today in this theater at 1:30. We have Yevgen from the JTNM who's going to report on the latest results from the latest JTNM tested event. And lastly, I just want to touch upon some of the ongoing activities of AIM. So of course, as I've mentioned, there are further additions to the roadmap under consideration. That's one important thing. And then we have two other significant projects that we've been involved with in the last year or two. The first one of those is called IPMX, which stands for Internet Protocol Media Experience. And the idea here is to bring open standards for media networking to the pro AV industry. And this IPMX standard is based on ST2110 and some of the NMOS specifications, but of course it's adding other elements that are required for the use cases that we find in the pro AV industry. So this is something we've been working on. It's a big project, and it's moving along well, and we're going to have a presentation today at 4 p.m. I believe that's going to talk about where IPMX is at, what sort of progress is being made, and what we can expect in the future. And then the last thing I want to mention today is an education initiative from AIMS. We recognize that as we move toward IP media networking solutions, people need to understand a lot of technical details, and they need to be educated. And we thought AIMS could play a key role in this education process. So we started this education initiative right at the beginning of this year. And we want to provide a resource for people to learn about IP technology for broadcast and pro AV operations. We have, in AIMS, we've been doing these kind of theater presentations here at the AES show, but also we've done presentations in NAB, IBC, we've done online events and webinars and so forth. And we've built up quite a big library of presentations, many of them made by the leading experts in the industry. And we decided if we could take that material and reorganize it and make it more accessible and useful, you could visit the AIMS website. And if you're interested in something like PTP, you can go to a folder, you can open it up, you can see all the relevant presentations on that subject. And we've got a number of other categories as well. So that's the first step of this education initiative. But we want to go further with it and create something more structured so that people can come to this education service from AIMS and really learn about the technologies and the standards and so forth. So you can see a link there to the current education library. We're also going to have a presentation tomorrow at 3:30 from the head of that project in AIMS, and he's going to talk about the objectives of the education initiative and where we're at right now with that. So I would invite you to attend that if you might be interested in that subject. So that's it for this presentation, and I think I may have run a little bit over. Oh, just on time, okay. But I don't have time for questions because I have run right to the end of my slot, but I'm going to be here in the pavilion all day today and tomorrow. I welcome the opportunity to speak to any of you if you have any comments, questions, any kind of discussion you'd like to have. But for right now, I'm going to turn it over to our next presenter. And next up we have Andrea.